Okay, so if we want to verify this trig identity, tangent squared theta times cosine squared theta equals 1 minus cosine squared theta, the first thing we want to do is start with the more complicated side. So let's go ahead and start with tangent squared theta times cosine squared theta, and that will be our given information. Okay, and these sides really both are pretty much equally nasty looking, so it doesn't matter which one you start with, you just have to pick one if you're not sure. Okay, and if we jot down our trig identity hexagon to help us recall the fundamental trig identities, off to the side here, we have tangent on the left, then sine, cosine, cotangent, cosecant, and secant, and the center always gets a 1. Okay, so if we look on our trig identity hexagon here for the things that we've got, we have a tangent here, we have a cosine here, and if you recall, when they are to the left and right of another vertex, they're a product identity. So the product of tangent times cosine is the sine function. So we'll go ahead and replace this tangent squared theta, cosine squared theta, that is equivalent to sine of theta, and that is using a product identity. Okay. So next we'll go back here to revisit our hexagon again and see what else it can tell us. So whenever we see a sine squared, well really any of the trig functions squared, and that's usually a good indicator then that you have a Pythagorean identity in your future. And those Pythagorean identities come from these three triangles on the trig hexagon. So this triangle here on the left reminds us that tangent squared plus 1 is secant squared. This one on the right reminds us that 1 plus cotangent squared equals cosecant squared. And then this one on the top reminds us that sine squared plus cosine squared equals 1. Since I have a sine squared, I'm going to go ahead and use that Pythagorean identity. So sine squared theta plus cosine squared theta equals 1 is the identity from the hexagon. And I'm going to solve that for sine squared theta by subtracting the cosine squared theta over to the other side. And that will be the Pythagorean identity. So instead of sine squared theta, I can write that as 1 minus cosine squared theta. And that's using a Pythagorean identity. And now we have shown what we set out to show, which is that 1 minus cosine squared theta that we were aiming for, right? Tangent squared theta, cosine squared theta, what we started with in the given, is now shown to be equal to 1 minus cosine squared theta.